They were winning World Endurance Championships, they were winning Le Mans, Daytona, World Rally Car programs. So they basically set up a meeting and said to them, look, how do you fancy adapting those products that you've got to a road car market?
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Ryan Griffiths, Technical Director of Cyvex. The Cyvex brand is one that's gained a huge amount of popularity and has seen a lot of success, particularly in the Nissan R35 GTR and the Lamborghini Huracan and Audi R8 markets. We dive deep into Ryan's background, find out how he got interested in cars, how he became an IT specialist, and then turned that career into an interest in tuning vehicles, obviously then moving into the development of the current generation Cybex ECUs. On that note, we also talk about the ECU technology and how far that's come from the likes of the APEX'i Power FC that he got his start with to the current generation of Cyvex ECUs and the Life Racing brand that they are closely affiliated with. This is a really interesting deep dive into the ECU development and specifically what separates some of the motorsport grade ECUs like Cyvex and Life Racing from some of the more garden variety aftermarket ECUs, particularly around some of their functionality. Before we get into our interview with Ryan, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune factory and aftermarket engine management systems. We also teach people how to build performance engines, build and design wiring harnesses. We also cover race driver education, race car setup, data analysis, and fabrication. And you can find all of our courses at hpacademy.com/courses. As a podcast listener, you can also use the coupon code podcast75 to get you $75 off the purchase of your very first HPA course. To make it nice and easy, we'll put that coupon code and the link to our courses page in the description. That's enough of our introduction though. Let's get into our interview now. All right, welcome to the podcast, Ryan. Thanks for joining us today. And as we usually do, let's start by finding out a little bit about your background. So how did you get involved in the automotive industry for a start?
So I was quite lucky when I was a youngster. My grandfather brought me a computer when I was just at the age of 8. And from that, I was kind of always quite gifted with technology. Some of my family were professional rally drivers. My uncle was doing the RAC rallies, was constantly taking me out in his latest and greatest car. So the two kind of coincided. And I started working for a local government with IT. And it wasn't really feeling it. So I started looking into the engine aspects, engine control, etc., doing lots of research and kind of finding a niche that I think that I'd work well with, which was obviously computers and cars. So yeah, we started my main thing was research. And back then it was a lot different to now. I mean, with the High Performance Academy, there's so much information available that it's almost a bit easier than it was back then. You don't certainly have it was all books back then and technical papers, lots of reading back then, and basically got into looking at kind of computer systems that were used in cars. So I think the first one I looked at was an APEX'i Power FC. I imagine a lot of people that are probably like my age that are calibrators probably have played with that.
Let's actually stop there and maybe give us a bit of a sense of what era we're talking about. Sounds probably like you're coming up through this about the same time I was, but just for our listeners, what sort of year are we talking here, give or take?
Probably 15, 16 years ago. So yeah, it's a similar, I think similar to yourself. So it was kind of the kind of go-to box back then. And I can't knock it. I mean, it was brilliant for what it did. Back then, it was really, I thought it was really good. I mean, they made plug and play systems that just plugged in. The base calibrations that came with them were pretty still. They were pretty good to get kind of most cars up and running for that era, if that makes sense. So I focused on the MR2 initially to start off with. Interestingly, a lot of the guys you have on the podcast always started off with Subarus, I think, like yourself. So I steered away from them. I'm not a big fan of those. So I went with the Toyota market, started with the MR2, and my brother and I were kind of working on those in our spare time. And I kind of got to grips with those and then migrated then onto its bigger brother, which is the Toyota Supra, and became quite a popular guy in the UK doing those. Most of the Supra guys will know. And from there, the Power FC it was very hard to source. I mean, you probably could find one Power FC for a Supra in like a year. It was very difficult to find one. So the only other product that was available at the time was the AEM system. So basically, I was using the AEM system a lot for the Supra, and it worked, and it did the job. But ultimately, it kind of led me down the path of looking on that platform. It was a huge market. I mean, in the UK and the worldwide, it was a massive market. So I ultimately looked into what products there were that could do kind of a better job. There was a lot of things I wasn't happy about with the other systems that were on it. So I looked into other products, and that's where obviously I found myself getting involved with the Cyvex things. Charlie, that owned a dyno which was called Surrey Rolling Road, which a lot of guys in the UK will know. He was very kind to let me use his rolling road when I was doing this development and getting involved with like tuning to start off with. The dyno is a great tool for that, for learning and kind of messing with values and seeing what effect it has on the car and the engine, etc. So ultimately, I've got a lot to thank for him. And then, funny enough, Charlie is now a director of Cyvex as well. So
Okay.
yeah, we kind of worked a long time together. So yeah, so that kind of got me involved with the calibration side from the start. And then what happened was obviously I got involved and said to the Charlie and Pat, who had basically started working on a product called Solaris. I said to them, "Oh, what's this? What's this product you've got? And it sounds really intriguing." And they showed me the software, and I was like, "Whoa! I mean, that's a bit a bit different to a Power FC." So I kind of spent a lot of time with Pat, who is one of the other directors of Cyvex. Got around the software, showed around it, and we got it up and running on a Supra. It was at that time, I mean, it was just like a complete game changer. I still to recall to this day, like back then, it was like there was nothing else that would come close to it in terms of a product. And obviously, Solaris is the early days of the Cyvex. So we got it up and running, got all the features working, the traction control working, knock control, everything that was available back then for that platform, even the automatic gearbox strategy. And then what happened is kind of the internet just took over. You fit one on one friend's car, and then their friend tells their friend, and the next thing I know, then I'm flying around the world setting them up, etc. So
Well, let's just park this for a second, Ryan, because you've dumped a huge amount of points here that I kind of want to go back and dig into.
go for it.
So let's kind of get back to the start. So you've mentioned your sort of love with the cars and computers, and I'm interested on that front. I mean, obviously you've moved on from calibration a lot here as well, and the skills for calibration with what you're doing now. Obviously, there's differences there. Is this all been self-taught with your IT skill set, or was there some formal qualifications that came in that as well?
No, so I just went to a high school, and then I went to a college to do IT. And then from there, I just literally went into an apprenticeship scheme at a local government doing IT. So basically, I was fixing computers for the local government and the councillors. It wasn't really my thing. So ultimately, there was downtime in that moment. So I just basically just read as much as I could, researched as much as I could, and kind of self-taught. Like most calibrators, I'm sure most of the guys having the podcast that I've listened to, a lot of them are self-taught.
Well, and the reality with learning how to tune, and this is how we got started. I went through obviously the same process around 20 odd years ago when I started tuning cars. And as you mentioned, there was no knowledge back then.
Yeah.
I mean, there's still a lot of people come through and basically don't do any training and kind of learn as they go and probably damage some engines that they didn't need to. So, yeah, I mean, definitely a lack of knowledge back then. What I'm interested, just for those listening who maybe want to go down that path of calibration, uh, do you need to be an IT specialist in order to tune an AEM or a Cyvex or any other ECU? Does that level of computer knowledge help you, or is it completely irrelevant?
For what I probably do now as a job, it helped me a lot. But back then, as a calibrator, obviously, ultimately, you are using a laptop which is being used on the computer system, and laptops have their quirks, like a driver's. You might have a driver issue, a cable issue, and stuff like that. When you're doing calibration, you're constantly in and out of engine bays, cables get damaged. So having some IT background was useful, but ultimately, I don't think it's really needed in order to be a calibrator. I mean, my best advice, as probably from a calibrator now thinking about it, would actually be to have some understanding of the engine kind of thing, learning about what the internal combustion engine does, how it works, etc. And then from that kind of then migrate into learning how to calibrate it. I've always felt like the best calibrators for me are the ones that understand where there's a problem and how to fix it.
Yeah, I've said this. I've said this a number of times already on the podcast, and we incorporate this into our courses. I mean, I definitely don't think that you need to become a mechanic in order to become a calibrator. That there's definitely a disconnect between those two skill sets. However, I think, at least in my experience, probably 1 in 5 cars I put on a dyno over the years would sort of go on the dyno, you'd tune them, and then they'd come off the dyno and leave with absolutely zero issues. And the other 4 out of those 5 are going to have some level of diagnostics required, from really minor through to probably something quite serious. And that's where the mechanical knowledge and understanding of the engine, the components, the sensors and actuators that are on there, and also an understanding of basic electronics does come in, because unfortunately, you can't sort of hammer away on the laptop and fix every problem from the comfort of the driver's seat. Sometimes you're actually going to need to go out into the engine bay and realize that the ignition lead's hanging off, and that's why you've got a misfire. And I think a lot of people these days who are fresh into calibration, that's what they want to do, which is fine, but they don't have that background basic understanding. So I think trying to incorporate both skill sets together, it's not essential, but definitely beneficial. Now, the other element I just wanted to talk about, you mentioned the Power FC, and I know I've had my share of experiences with the Power FC in New Zealand, where we're lucky enough that we get a huge number of Japanese domestic market imports from Japan direct, and a lot of those cars were coming into New Zealand with Power FCs already fitted. So, you kind of had to learn how to work with them. And I 100% agree. I mean, at that time in particular, they're actually a pretty powerful unit. Where did you sort of see the limitations of that unit that sort of led you to the AEM platform, which was available at the time? Or was that purely around the shortage of not being able to get the Power FC product?
I think what it comes down to for me was just more the reliability of the engine aspect. The Power FC was great at controlling the engine. It would do a good job of actually kind of making the power and getting it running and such like that. But it was no good at kind of any safety aspects. I mean, the knock control, for example, would just have a warning bar that was on your what was it called? The hand
The
part.
hand controller.
Commander, was it the Commander? Was
Yeah,
it
that's
called?
it. Yep.
There we go.
Yeah.
Yeah, we're going back now. And it had the bar graphs that kind of warned you about the knock, and it would throw the check light up. I mean, it wouldn't take those guys, the engineers, much to basically, they've got a really, the knock control system, the detection was really good. It works really well. Just to literally, even if they just flew a global timing reduction or something in there, just to kind of make that work, that would have been instantly a better product. Obviously, then at that point, there was no kind of traction control. There's no kind of ways to control the power. And the thing is that, obviously, you and I will both know this, is that the level of kind of torque and power that we were involved with back then compared to today is insane. I mean, it is unbelievable.
Things have escalated. It's gone exponential, and you're absolutely right. I mean, the requirements for torque management or gear dependent boost and launch control strategies and traction control strategies probably really weren't that essential when you've got a Supra that's maybe making 400 or 500 horsepower, and now when they're regularly making 1,500 to 2,000 wheel horsepower or more. Obviously, it's chalk and cheese, so the requirements of the ECU escalate with that.
So that's why I moved on to the AEM, because the AEM did have like a knock control system on there, and it allowed you to put additional I/O in. So I was interested in monitoring kind of the oil pressure, fuel pressures, setting up trips for those. Basically, I mean, ultimately, for me, when I was calibrating, when a car left me, I kind of planned to not want to see it again. That was my aim. I knew if I did a good job, if I didn't see it again, in terms of knowing that the car hasn't blown up, if that makes sense, and ultimately is the customer is happy, if that makes sense. So that was my aim. The Power FC, like I said, could make the power and stuff like that, but I'd always have to be really conservative with the final kind of numbers that I left in it, because I knew that I had to give myself a bit of margin there, so that if the person did put a bad different type of fuel in, or something was wrong with like the crankcase system and it's sucking in oil, etc., I know that it's basically going to be able to survive. So that was the kind of why I moved over to that. And then from there, obviously, then to the Cyvex, which I can talk about later about why I moved on from there. So yeah, I mean, it was, I don't know if it's difficult when obviously you're talking about other brands, etc., like that. Obviously, and it's a lot has changed in that time. But back then, one of the main problems I had was the reliability. The Power FC was, for something that was super basic, was really reliable. I mean, it would take a lot to kill one of those. When I then merged to the AEM system at the time, I was having constantly problems with the hardware, which was difficult in maintaining that relationship of me saying that when a car left, I didn't want to have to see it again, if that makes sense. I was then having customers ringing me up and saying, "Oh, the car is misfiring. We've changed everything. Everything is fine. It's got to be a tuning issue." And that's kind of a classic thing as a calibrator. You'll find is that ultimately a lot of the time it'd be of one of two things that normally get blamed first. It's either the calibration or the ECU that is at fault. It's never going to be the spark plug or the lead or maybe a vacuum pipe has popped off. It's always going to be the ECU or the calibration. So the next thing for me was to basically go above and beyond what safety aspects I could do. And when I looked at the software that Pat showed me back then of the Solaris, which is now Cyvex, I was just blown away. I mean, there was safety trips for everything, and then that then allowed me to kind of push that and move that into the Supra. So yeah, it was a natural path.
I think that's something I definitely saw develop over time. You're 100% right. The ability to have sort of engine protection strategies inside of the ECUs, and I think it's really easy to sort of overlook that. And to a degree, like we were saying, when the engines aren't producing a huge amount of power, the operational window where you're not going to hurt the engine becomes quite wide. But when you take that 300, 400, 500 horsepower engine and then double or triple the power, that operating envelope where the engine's not going to destroy itself becomes a hell of a lot more narrow. And you definitely want to, where possible, have some protection in place in case something goes outside of the norm. And of course, these days, those strategies are relatively common across most of the brands. But like you're saying, back then it was unheard of, essentially, wasn't it?
Yeah, I like to think that we kind of we have this kind of motto in the office, like lead the way. I like to think that we kind of push that in the market, and other systems then obviously kind of caught up on that and followed with that. It was important for us as a brand and from a calibration point of view that we had as much safety as possible. Be it, I mean, there's a ridiculous so many like fuel pressure, oil pressure. You've got a lean lambda, you've got knot control, crankcase pressure, coolant pressure. I mean, the list goes on and on. And then you've got warm-up limps, so the water temperature's got to be within a certain operating window before it allows you to increase the rev limiter or the throttle opening and stuff like that. So it basically not only safeguards the engine from a calibration point of view, but also from the owner. Sometimes, I would see someone just literally get in their car from stone cold and instantly bring the thing onto boost, and you see the blue smoke coming out where the oil pressure is so high. It's just it just cringes, and it's.
I 100% agree. I in my own business, I was both building and selling engines as well as doing calibration, and I would incorporate exactly what you're talking about there. Something where either the boost limit was lower or the RPM limit was lower when the engine was cold, and you can sort of tell with some customers, you got a sense of this guy or girl, not a lot of mechanical sympathy probably here. And of course, it's not just about giving the customer a good tune that they're going to be happy with. When you're also selling the engine, it's about protecting your reputation with the build of that engine. And like you're saying, I mean, if they're going to jump in the car stone cold and hit 2 bar of boost as they're leaving their driveway, that's not a great thing for a freshly built engine, or any engine for that matter. So I do remember there was a couple of situations where I'd tune the car and I'd bring in this sort of engine temperature based RPM limit, and you'd send the car back to the customer, and a couple of days later you'd get a phone call like, I started the car and I got a misfire as I left the house or whatever, and you sort of talk them through it like, were you driving it quite hard? Oh, maybe. Okay, well, this is why. I kind of figured at the end, like, education around what I've done and why I've done it was the other key. Another interesting aspect with that, most ECUs these days, you can password protect them. And this gets to be a real controversial topic, which is definitely a little bit off topic, but we'll mention it while we're going here. I'm not a big fan of locking my tunes. Other tuners will talk about intellectual property. There's arguments about who actually owns that IP, whether it's the tuner or the customer. I'm not going to get into that battle, but I mean, in the most part, I don't lock my calibrations. There's nothing that someone else is going to learn from it. However, there are occasions, and again, you sort of, when you're in this industry for long enough, you get a bit of a read on the customers that are likely to jump in there and have a bit of a tutu and play around. So what I'd do is occasionally when I had that sense, I'd lock the ECU. And then sure enough, a week or a month or 2 months later, you get a phone call, hey, this ECU is password protected. And I'd be like, yep, here you go. Here's the password. Have at it. Just understand at this point, if you make any changes and there's an engine problem, that is now 100% on you. And I will know that you have had a play with that. And that's just usually enough. Oh, yeah, okay. So I'm not going to actually play with that anymore.
Yeah, and it's quite funny, obviously, hearing instantly you jumped to 2-bar. When you said 2-bar, my old company with tuning was called 2-bar tuning, because back then,
That was
2-bar, obviously, and to a you and I back then, it still sounds
Not
like
anymore.
a lot. Whereas now it's like it's just so it's
Yeah.
too low. But yeah, no, the password thing is an interesting thing, like you said. I don't want to get into it, but that was another reason that drew me towards the Cyvex when I was getting involved with it, is because it had the logbook. So the logbook was brilliant, and data logging, because there have been numerous times where the customer would say to me, like, no, I was just driving down the road like completely normally in it, and now it's misfiring, and it's like, yeah, let's just have a look at that data and see what happens at 9,000 RPM or something, where you've selected the wrong gear, or
Yeah.
So yeah, that was what drew me, and that was the protection. I mean, that was the main thing that drew me to it. Was ultimately, if you're going to be putting your name on something, you want to make sure that it's going to be good.
You have to be able to protect yourself as well.
Yeah, exactly. I mean, I've seen so many people get burnt by one person, if that makes sense. The internet is very powerful like that. It is a very powerful tool.
It can go both ways. If you've done good work, that will spread like wildfire, and just as quickly if you've got an engine that's had a problem, then that'll spread as well. Mentioning the logbook, I mean, another ECU here that I used to tune a lot of had a similar feature, which was a statistics page, and most customers, if they weren't too savvy, they had no idea that existed. And what it would do is simply log the maximum values. So you'd have peak RPM, peak manifold pressure, how many times it had hit the rev limiter, a few other parameters as well. And that was an absolute gold mine of pulling potentially some customers up who are maybe bending the truth a little bit. And you sort of say, well, hey, look, it's set on the rev limiter and hit that 8,000 times. So, you know, in the 3 days you've had the car back from me since I tuned it, that's not normal behavior. So let's actually investigate how you're driving this car and see if we can come up with a solution that's going to keep your engine alive and keep you happy. And, you know, that normally sort of makes them see reality a little bit different. However, we've got a little bit off track. So let's get back onto things here. So you've mentioned Solaris, which then became Cyvex. And I mean, it's no secret as well that there's a family relationship between Life Racing and Cyvex. So I'm interested, can you tell us how that relationship works and how Solaris developed into Cyvex, etc.?
So Pat and Charlie were the ones that actually created Solaris. I tagged on a little bit later, a couple of years later, and they basically would share the same emphasis with me, with trying to find something that would better than everything that was around. So naturally, what you do is you kind of look at other ECU manufacturers that are around, and Life Racing was obviously a British company. They were just down the road from one of the directors. So they basically set up a meeting and said to them, look, you guys are like one of the best in the business for the motorsport aspect. How would you like to take some of that road car market, which they did nothing really with at that time? I mean, they were winning World Endurance Championships, they were winning like Le Mans, Daytona, World Rally Car programs. I mean, they've got a heap of success, especially being linked to AER, Advanced Engine Research. They had an amazing tool set of the two companies coincided of having not only the kind of brains, they also had the guys that were able to build some of the best engines in the world. So the two worked so well together that it was logical for us to go to them and say, look, how do you fancy adapting those kind of products that you've got to a road car market? So yeah, like I said, Pat and Charlie went to them. They initially got it set up to work on the Subaru platform, and that was successful. They would sell. I mean, it was quite small. That when it was back at Solaris, I think they were selling maybe 5 or 10 ECUs a month, mainly just to Subarus. And well, like I said, when I then saw the potential of it, I basically said to the guys, I said, look, there's a lot of potential here. How about I help you transform it into obviously being able to cater for lots of road cars. So what happened is I bought shares in the company and then invested years of time developing that to work on the road car. What that meant was, initially at the start, obviously we were just using the Life Racing hardware and the existing strategies that they had done. As that kind of went on, and I think Life Racing then started realizing, well, actually, these guys have got a serious kind of business platform here. They then started allowing us to kind of get involved with the strategies we wanted. So the a boost control strategy for, say, like a world touring car, it wouldn't suit a road car from a drivability point of view. So what we did is we basically changed the wastegate control. That was one of the first things that was changed. We did that for a road car application, and then the product went on. And obviously, as a race car, they weren't really looking at too much things in terms of drivability and stuff like that. So like the overrun fuel cut was pretty much non-existent. It didn't have that. The idle control was quite basic. So we basically worked with them to basically say, look, let's make this like a road going ECU. And as I said earlier, I mean, back then there was nothing that came close. Honestly, it was just in a league of its own completely. And it allowed us to take all of those strategies that were available back then, like knock control. They had drive by wire back then, which no one that I knew of had it on an ECU. A traction control system that was winning Le Mans races and stuff like that. We enabled us to basically take all of that IP and kind of strategies and make it into a road product. And on the Supra, which was the first product that I worked on, it was a complete game changer. The traction control on a Supra was just unbelievable. We wired in the bipolar inputs for the VR sensors that were for all the four wheels. Got some great data. And then I remember like the first time that some of the customers drove it, they were just like, "Oh, there's something not right. The engine's not right. There's something not right with it. It's not making this." And it's just the traction control strategy is just working so well in keeping it straight. And it was amusing, just literally just saying, "Well, just turn that switch off and give it a try," and literally watching them nearly like crash the car. So yeah, it was a logical decision for us to use the hardware and the IP that they had back then to kind of make it into a road car market. And then ultimately in 2012, we then did the R35, started doing the development on that. It was a huge jump for me personally to jump into a car that was so technologically kind of like different to anything else that was on the market, to learn about all the CAN aspects and that we then had to start making additional hardware to work with their hardware to make this package.
Right. Let's just stop you again there, Ryan, because I want to just come back to a couple of the things you've mentioned there. Yeah, as you sort of alluded to there, Life Racing kind of working at that upper echelon of professional motorsport. So it sounds like at that point when Solaris, Cybex got involved with Life, they really didn't care about that road going market. They're very focused. A lot of the feature set and the strategies that have come through from Life to Cyvex are developed in the likes of Le Mans World Endurance Championship, etc. So you've got some professional, absolute professional level strategies there. A couple I want to talk about. So we'll talk about the traction control because that's quite interesting what you just mentioned. But before we do that, you mentioned the boost control strategy that they had for the touring cars, and you found that actually wasn't suitable. I'm interested, where were the sort of problems with that strategy that made it not suitable for a road going application?
It was more the LMP side of things. So anyone that's used the Cyvex software, it's probably not, I don't think it's in the actual Cyvex software anymore, but they had an LMP dedicated boost control strategy. And ultimately, what they're trying to achieve in Le Mans is obviously keep the engine going, reliable for the 24 hours, but ultimately keep it in a power band where it's got the the largest amount of torque curve that's possible, and obviously a linear torque supply, so the driver can basically kind of out of an apex accelerate like in a linear fashion. They don't want it to be too kind of sharp, if that makes sense.
Mm-hmm.
With a road car kind of engines, the turbos are generally kind of a lot different in their transient response. They would be quite snappy and stuff like that. So what we actually wanted to do, a lot of customers would basically say, oh, they drove it and it would be kind of a bit too linear, the power curve. They wanted to have that initial kind of oomph of feeling the torque of stuff like that. So we had to kind of get a bit more wild on the PD tables, which allowed us to basically chuck in a load of duty at very kind of large errors to get the turbo spooling as fast as possible, and then kind of controlling that as it came up onto target. With the LMP strategy, they were more interested in keeping it on boost rather than getting it on target, if that on boost, sorry, so to speak.
Sure, yeah.
So that's what's quite different.
I think there's a lot of tuning advantage in how the boost control strategy is calibrated versus driver foot pedal position, because the problem I see with a lot of turbochargers, or most turbochargers, they're really, really good once they're beyond their boost threshold at making boost pressure and holding boost pressure. And from a driving perspective, particularly in a race application, if you're at 100% throttle and maybe 5,000-6,000 RPM and you back off to maybe 50 or 60% throttle, the wastegate essentially closes and drives the turbocharger, or provides more exhaust gas energy. So the turbo is still producing the same target boost it had at 100% throttle, and the engine might still be making 90% of the torque it did at wide open throttle. So that's very non-linear in its torque delivery, which it makes it hard sometimes for the driver to actually control the car. So yeah, I can see the requirements for some differences there. Coming on to the traction control, because this is something that I've noticed as I've gone through my career, and it sort of comes down to a supermarket shopping list of features that absolutely every ECU has. And these days, I don't think you'd probably find an ECU that doesn't have a little tick box beside the traction control strategy. So, as the casual consumer looking to buy an ECU for the first time, you're like, yep, okay, traction control, we've got it, knock control, etc. And it's not till you actually experience some of these features, maybe on some of these more entry-level sort of targeted ECUs, that you quickly realize that there is traction control that will stop the wheels from spinning. Great. And then there's traction control that will limit wheel spin, maybe optimize that slip ratio, and actually allow the car to be exceptionally fast in marginal conditions. And those are again, sort of chalk and cheese. I experienced that with one of our own race cars. I won't name the brand of ECU, but when the car got a bit of wheel spin, you may as well have turned the ignition key off. I mean, yes, it stopped wheel spin, but you could get out and just about walk faster. So, where are the differences if we talk about this traction control strategy? Because you obviously experienced this in that Supra market. What was it that the product was doing that was so good, and how was it managing that traction control?
Well, ultimately, data is key in any application, and being able to get that data service fast is also key with traction control. So one thing that Mark Colby, that is the head coder with the source code that was doing the traction control, it spent so much time on basically making sure the data was accurate, if that makes sense. So the wheel speed information that you were getting in was coming in as fast as possible, looking at a high resolution, high teeth count. So you've got a good, accurate representation of what the wheel is actually doing. Once you've got that, controlling it is then in a completely different manner. The strategy's obviously got to be service fast, and the main thing that I'd say that they had that was differently was that the slip angle wasn't just based on a particular single variable, if that makes sense. Your slip angle changes based on the many aspects of basically allowing the car to accelerate as fast as it can. Like, I think everyone thinks initially that with a tire, having it that is with no spin is ultimately where it is most grippiest. It's not always the case. I mean, a lot of tires will be, if you look at a plot long G, you'll find that they work best at like a slip angle of like 8 or 10% around there. So having a system that controls it, but also targets a certain slip angle that you want and does it well, is key for a good traction control system. And another thing is that ultimately we're doing it based on not only wheel speeds. We've got obviously yaw you've got lateral G, steering angle, and then you can feed in GPS as well to have the traction control set up differently for different parts of the circuit. So if you've got a GPS sensor and it's wired into the ECU, you can basically set up on different parts of the circuit where you want to manipulate different areas of the traction, which is quite key. And obviously from the pits, it allowed them to be able to change stuff as well if the weather was changing, if the race series allowed that functionality. But yeah, coming back to obviously what you're asking, I mean, I've seen ECUs that do it based on RPM derivative. So they basically look at the acceleration rate of the RPM and look to control the traction there. And then I've seen other people use obviously the wheel speeds, and like you said, are just literally just providing a pure cut. Not only are we kind of just adjusting the kind of engine's torque via cuts, timing, and stuff like that, the way the cuts are done is also a really important aspect of the traction control. If you do 100%, like say a 50% fuel cut on every single cylinder, the way that the powertrains and the kind of everything that's in your powertrain reacts compared to having instantaneous cuts that are applied over each cylinder in the kind of the firing order controls the way in which the power is kind of decayed back in on and off of traction control, which is a really important aspect of traction control. Is not only just controlling it, but ultimately when you come and exiting the traction control, you don't want to suddenly ramp back into spinning the wheel again. And keeping the temperatures under control as well is an important thing. Obviously, if you've got a lot of retard, you need to understand that at some point you're going to have to start cutting fuel to reduce the temperatures in those cylinders, and having lots of things link into that. I mean, it's difficult. Obviously, you don't want to give too much away as an ECU manufacturer, because our ECU is very well known for providing a very good traction control system. So I don't want to allude too much into other stuff that we do,
Sure.
if that makes sense. But hopefully that
We'll let you keep some of your secrets. I'm interested though with the sort of just going a little bit deeper, and again, you feel free to give us as much or as little information as you need to here. You know, with the traction control strategy, you've got options available on how you're going to reduce the engine torque. You've already kind of mentioned this. You can cut fuel, you can cut spark, you could cut both of those. You could retard the ignition timing, which also reduces the engine torque. Yeah, when you're talking about the calibration of a traction control strategy on a small cylinder count engine, let's say you've got a 4-cylinder versus maybe a V10 or a V12, yeah, is the way that you approach that different? I'm guessing, talking about a 4-cylinder engine, if you're going to have an individual cut event, clearly you're cutting one cylinder, so you're instantly reducing your minimum reduction is then for 25% of your engine torque.
Exactly.
Obviously, on a V8 engine in comparison, one cylinder cut is half of that again. So, does that come into play as well? Does it get a little bit harsher or more coarse, I guess, on small cylinder count engines?
Yeah, and that's why I was saying about the way that the cuts are applied is quite important from the ECU strategy side of things, and that's what I think differentiates a lot of different traction control systems, in the way that the cut is applied and the way that the kind of limiting system is actually being applied to the engine. But yeah, like you're exactly right. I mean, if you've got a 4-cylinder and you're shutting down one pot, obviously you're going to be reducing a huge amount more. I think the main thing that you see when you do that is you get larger oscillations in your kind of your spin error and stuff like that. So when you have that kind of scenario, you play more into having the mix of the cuts and the timing, and this also changes massively as well with a direct injection engine. With a port injection engine, you've got a transient event of how long it takes the fuel before it actually kind of lights up. With a direct injection engine, obviously the injector is already in the combustion chamber, so if you do a fuel cut, you're instantly cutting the torque generally. Whereas a port injector system, there are latencies there, and being able to kind of understand and preempt how much that latency is going to be is also important for knowing how much torque you're going to need to reduce in order to reduce that spin. So obviously you can do ignition cuts and stuff like that, but ignition cuts are quite harsh on the valve train of an engine, and we try to kind of only use those in like the real drag applications where they want to keep that exhaust temperature and pressure as high as possible to keep the turbine working at its maximum. And then that's another aspect of the traction control in ensuring that not only are you killing the torque through the kind of drivetrain to get the car back under control, but you've also got to make sure that you're not killing kind of your turbine energy that is available, especially on a turbocharged car, so that once you have resolved your traction issue, all of a sudden you've then got no torque at all. So I think that's what sets it between the kind of the men and the boys when it comes to the traction control strategies.
Yeah. Two elements I'll just dive into a little bit further, because I think these are really important, and just what you mentioned there with ignition versus fuel cutting. And I think this is something that, if you haven't experienced the potential expensive failures that can result, it's easy to not understand the potential problems. But depending on your engine, a lot of engines are very sensitive in the valve train. I'll give a couple of examples there. The older style Nissan SR20 DE and DET, obviously a pretty dated engine by modern technology standards, but a really heavy rocker that wasn't shaft mounted, and almost any level of ignition cutting on those can end up popping the exhaust valves back off the seat, and then the rocker pops off and the rest is pretty ugly. Likewise, a shim on bucket or a shim on valve type valve train arrangement, we can essentially have the same thing with the shim being thrown out, and the resulting damage is pretty nasty. So fuel cutting, on the other hand, doesn't give that energy in the exhaust that can then explode and cause pressure pulses to pop those valves back open. So if in any doubt at all, fuel cutting is definitely the preferred method because it's safer. But as you say, there is an energy to the turbocharger that is reduced as a result. So this is why we see a lot of times in drag racing, there'll be some quite specific modifications to the valve train on the engine to make it cope with using ignition cutting. Not on the relation of traction control, but the two-step launch control strategy we use to spool large turbos exactly the same. Really, for that to be effective with a huge turbo on a small capacity engine, we need to be using ignition cutting. We're still pouring fuel and air out into the exhaust system where it's going to ignite. That's driving the turbocharger, but it gives us this problem with the pressure spikes in the exhaust manifold, potentially popping the valves back open. So there's that element I just wanted to clear up so that people have got a bit more understanding around fuel versus ignition. Coming back to the traction control, you sort of mentioned there, and you've kind of alluded to some of the solutions anyway. You mentioned there that a slip wheel spin ratio of maybe 8 to 10%. It's very dependent on the tire. That's actually going to give you better acceleration. So for drag racing or anything where we want to accelerate in a straight line, that's obviously ideal. We want to target whatever's going to give the best grip from the tyre. But I think a lot of people think, well, that's that magic number. So let's say it's 10%, that's what I'm going to target. And that's fine from a standing start. I mean, if we've got 10% wheel spin, we can probably manage that from 0 to maybe 60 mile an hour. But if we're still targeting that 10% wheel spin at 120 mile an hour, things can get out of shape pretty quickly, and likewise, if you don't take into account lateral G-force, if you're cornering, 10% wheel spin's probably going to have you backed into the barrier on the outside of the track pretty quickly. So incorporating all of these into a strategy is what really makes it work well in a race application, correct?
Yeah, exactly. I mean, it's not like you said. I just kind of picked those numbers out of my head with the 8 and 10%, and like you said, a different tire will have a different amount, and you almost want a larger kind of slip as you're leaving the line, kind of thing, to get some heat into the tire. But yeah, you're exactly right. If you, in a circuit car, as you start to load the tire, the sidewall of the tire, etc., and stuff like that, that has a different effect of how the tire is going to react as well. So I think one thing that is important to say is that it's not just about initially just say targeting one aspect of a slip target. You need to have that adapt for not only the kind of tire you've got, the surface you've got, the temperature you've got in the tire, the pressure you've got in the tire, the location you potentially are on a certain part of the track. Say for a rally car, for example, certain stages you might have a tarmac versus a gravel. So that's where having adjustability for the driver as well in the cabin with like a traction pot, which we can provide to some of the teams if they don't have the GPS kind of information coming to them. That is also quite useful as well as a driver, that they can on the steering wheel adjust their traction control just if they know to a certain part, or if the weather's changed, for example. If all of a sudden it started to rain, you want to tighten up that slip angle. Having a pot on the steering wheel or in the cabin, allowing you to tighten things up to adjust that slip angle and your gains as well. Because it's not only the slip angle you need to change when the weather, obviously the conditions change. You need to change the amount of torque reductions that you apply as well, generally, because if you have too much cuts in the rain, for example, you can actually cause a kind of the drive chain to kind of go into oscillation, and then find that you have more problems. Traction control is something that is not just something that is you just tick a box and it works, if that makes sense. You need to have the understanding and calibration. And coming back to what we said earlier, with the way that the cars have changed over the years, the danger now is that you've got these kind of 3,000 horsepower kind of V10s and GTRs that you can set up on the dyno safely, and you can get your torque in that. When it then comes to setting them up, not everyone's got the budget to go and hire a drag strip. So what do? They go and use the road to set it up. And it's really important to make sure that people that are getting into this tuning, that are going to be doing the traction controls, accept the safety aspects of that. Because if you are setting up like even a 1,000 horsepower car, a rear wheel drive car on the road and trying to set up the traction control, if you set something up wrong and all of a sudden it turns off, things can go bad very quickly if you're not a particularly good driver, if that makes sense.
Absolutely.
And me personally, I know I've lost already kind of 2 or 3 friends in the industry since growing up that have been calibrators that have died in testing cars on the road. So yeah, I can't. While the traction control is really good and stuff like that, ultimately it needs to be set up by a professional and in a safe environment, I would say, as well, because the road sometimes isn't always the best place for that.
I mean, the feature is obviously, no matter how good that feature is, it's still only going to work as well as it's been set
Yeah.
up or calibrated to do so. I don't want to do this to death, but a couple more things that I want to just dive into on this particular topic of traction control. I'm interested in your own calibration strategy in terms of not the traction control settings itself, but there's 2 ways I see this approached. A lot of tuners will have essentially feed all of the power and torque into the engine that it can handle, and then set up the traction control and let that pick up the pieces in the background when it overwhelms the amount of traction. My strategy has always been, wherever possible, I think it's probably comes from my drag racing days, and particularly at the time I was drag racing 4-wheel drives with no form of traction control because we couldn't. But I was always trying to, wherever possible, as closely match the torque delivery of the engine to the available traction. And then, and I still do this with our circuit racing applications, then if I've overstepped the mark by a little bit, rather than the traction control needing to pull back 60% of engine torque to get the wheel spin back under control, hopefully if I've done my job properly, it's only needing to pull back 5 to maybe 15%. What is your take on those 2 different angles with traction control tuning? Or more, it's not really traction control tuning, it's more torque tuning.
Yeah, I mean the two different things are completely different in terms of drag racing and circuit are different animals. With drag racing, ultimately you're wanting to maximize the torque, the turbo availability that you've got, the torque available that you've got available from the system, and that's where the torque control systems become really, really good at that. Because especially with a drive-by-wire assisted car, you can maximize your kind of mass air that is accumulated before the throttle body, and then kind of at the same time have enough mass air in order to control the torque that you've got available. So where you're at a lower kind of like in a lower gear, for example, and you're kind of more likely, you don't want to be running kind of peak torque and stuff like that. Having that availability of drive by wire as another add-on in the traction control, and being able to target, be it a boost target that you want or a torque target, if the ECU supports torque control, it is, yeah. Ultimately, you don't want to be riding on the traction control too much. And the other thing is when you do the drag racing stuff, sometimes the tire data is not good enough. So that's where you kind of look at external speed sources, or you even look at your engine speed and target an engine speed on pull away instead of a particular slip angle, because on some of the cars your front wheels might be up in the air, at which point your reference speed is useless. So that's why obviously we then made products to kind of suit that situation. But yeah, I think the main thing is, like you said, as when I first got involved with it, it was kind of all based on wheel speed because the torque control systems weren't around then. Drive-by-wire wasn't really used on cars back then. Now that drive-by-wire is available now, it's another kind of way of being able to control the torque, which ultimately, you're right. If you can kind of get the torque where you want for your drive ratio, and then have the traction control sit on top of that, it's going to be better. But with drag cars, at some point you are going to have to be trying to maximize that turbo energy, targeting a turbo speed that you want, and making sure you're not over speeding the turbo. And like you've done in some of your other videos where other people have used kind of the drive-by-wire as a way to bleed off the air from the turbo, that's another great way of doing it as well. So yeah, the future is, I mean, the future's great. I mean, seeing that, I feel quite lucky seeing it evolve quite as much as it has. And I wonder what it's going to be like in another 10 years' time. Probably not going to be any internal combustion in the mix then. I think those days will be maybe gone. But
Cyvex EV control, maybe.
maybe, yeah, I'm not sure. I'm not set on that at the minute. The EV. I mean, one of the best cars I've driven is a Porsche Taycan, which is an EV. I think mainly because I'm used to being in loud cars all the time. I suddenly, when I'm just driving home, and I've got phone calls to make or suppliers to speak to, I just want something quiet. So the EV, that's what it ticks. It
Definitely.
ticks the box for me in that regard. But traction control is a lot easier on an EV than.
Well, you've got that instantaneous. There's no latency in the response. You ask for a reduction in torque, and
Yeah,
that's what you've
yes.
got. Understood. One last topic on this, and again, I don't want to sort of do it to death, but it is interesting, and I'm sure a few people will have this particular question in mind as well. Traction control, you've kind of already alluded to the fact of bringing in external speed sources because the front wheels might be in the air, but the problem that I faced back with my old Evo drag car was I had a four-wheel drivetrain with a lock center differential. So if the front left wheel was spinning, so were all other three wheels. So wheel speed was essentially useless. Now, yes, we can look at essentially the drive shaft speed versus or engine rate of engine speed change through a gear, or drive shaft speed versus the 400 meters, and what the ideal profile of that drive shaft speed should be. Sort of I call that a passive traction control strategy. If we get a spike in drive shaft speed, that generally is going to mean that the car's wheel spinning, and we can do something about it. But the other element that I'm interested in is GPS-based traction control. And I think a lot of the GPS units out on the market are relatively low frequency, sort of 5 to 10 hertz. And if you really sort of get granular with what that data looks like and you overlay it over a wheel speed signal, I mean, it's very sort of, it steps, obviously, it's updating 10 times a second. And clearly that's not going to be sufficient. But I mean, I've got one of Cyvex 50 hertz GPS units in one of our cars at the moment, and the data is absolutely incredible. I believe you also make 100 hertz GPS. Does this become a valid option then? And I know years and years ago we actually interviewed a Cyvex customer, Andy Forrest, who came over to World Time Attack, and he was using that strategy on his Subaru WRX. But yeah, how well does that work? Is there any downsides versus a wheel speed input?
I mean, the data from those 50 hertz and even the 100 hertz, as you said, is good enough to be used for a traction control system for sure. We still have a little tick box that the calibrator or the owner has to kind of say to tick to basically say that you are going to use GPS data for it, because the only problem you've really got with the GPS is that if the satellites are not in view, or you've kind of got interference, then obviously you're ultimately going to have problems with the data. So our ECUs have lots of safety fallbacks for that. So in the event of, say, the GPS data not being good, we'll then start to look at the accelerometer data to see, and we can work out kind of a speed from that. If that's no good, then we can use the original wheel speed. And if that's no good, then you can put it into like a limp mode. But yeah, ultimately, yeah, as Andy Forrest, I mean, that was a great video that you guys did a few years ago. He's been using it a long time. All of the R35s, GTRs that are pretty much in drag racing are using that 50 hertz. All of the Lamborghinis, even on the road cars, they use it. I mean, this year alone, we've sold hundreds of those 50 hertz to the R8 guys and the Lamborghini guys that use those not only with our system, we made it work with some of our competitors' systems as well. It made sense. I mean, ultimately, if you can make something that provides really good data, then why not offer it to everyone, if that makes sense? So, yeah, I think the only downside is if you hit a tunnel. If you come into a tunnel, that can ultimately be a problem, and that's where you have to have the good feedback that what do you then do next in that instance. And ultimately, I think as long as you've got a good antenna placement, I mean, one of the things that I've seen is that the the kind of the product's only as good as the kind of placement you put it in, if that makes sense. That like a G sensor, for example, you wouldn't put the G sensor right at the front of the car, if that makes sense, because your all your angles are going to be out. Then it needs to be in the center, as low as gravity as possible, center of gravity as possible. And the thing with the GPS is that the antenna really needs to be as outside of the chassis of the car, away from kind of any metal that's going to kind of be providing like a Faraday cage that's going to be stopping the kind of the information coming in from the satellites. So, and the other thing I've seen as a classic thing is people's cable tying the antenna cable to the roll cages, and then ultimately, yeah, kind of creating a damaged antenna over time. So, yeah, I mean, I'm very proud of that product. Like you said, it provides really good data. The refresh rate on it, obviously 50 hertz, is kind of is as good as having kind of like a 22 wheel on your ABS system. Most OEM cars generally will have now like 40 plus. The more teeth, the more resolution you've got, the more data you've got available to be able to see how that speed is changing. Um, so that's what we thought. Look, 50 hertz is a great product. It sells well. How can we make it better? That's kind of our emphasis. Is we always think, how can we make this better? I think if you sit there in development and just think, oh, okay, well, this is the best thing there is available on the market. Let's leave it there. You're never going to really go places. So we kind of took that and thought, look, what can we do better with this? So the 100 hertz was ultimately the next evolution of that, and I'm sure my team can get you one out for your car.
I'm interested with these particular products. Is this a standalone Cyvex development, or is this still
Yes.
being done with Life?
No. So back in 2012, I said a bit earlier, we kind of started making our own products. So most of the stuff that you see now from Cyvex, the ancillary units and the S7 Plus, the S7i, etc., these are Cyvex created products that we've used. With the engine ECUs, we still use the great IP and strategies that Life have done with the engine ECU platform from years ago. And then what we've got is we've got a branch of software that has generally got our stuff in it that we need for road cars. So while the LR and the Cyvex calibrations do look kind of similar when you look at them, there are differences there that are stuff on there that's based for our platforms. But yes, to answer your question, all of the new kind of products that you see, the DI12, the GPS modules, the expander modules, the all drive modules, they're all developed in house and done by Cybex.
Okay. Now, on that note as well, the relationship between Life and Cyvex, I mean, I've seen these sort of relationships with other brands of ECU over the years. I can't think of another one that I've seen that's kind of lasted the test of time. What is it about the Life/Cyvex relationship that you think is still as strong, made it as strong now as it ever was, or maybe even stronger?
I think it's knowing where your markets are. The thing that I've seen fail with other relationships in the past is that they almost then become competitors. And then what happens is that creates problems internally. We kind of know that we're kind of focused on the road car market, and Life are generally focused on the military, kind of the world championships, rally car stuff. So I mean, we get inquiries all the time. For example, can we provide an ECU package for a rally series, for example? We generally, what we do is then just say, okay, well, look, you need to speak to our sister company, which is Life Racing, and they do the same with us when it's road car stuff. So I think that's
So you stick to your lanes.
yeah, exactly, and I think that's what makes it it makes it work, if that makes sense. I think in all the years we've worked together, I don't think there's actually ever been a situation where that we've ever had a kind of crossing that's caused a thing. Yeah, I think that's why it's worked so well.
I go a little further as well. What I see from the outside as well is you've actually got a significant physical differentiation between the two products in that, for your road car market, and we're going to get into this, the CAN integration that you've done for the Cyvex product to work with all the other controllers in the car, at least as far as I'm aware, you can't buy a competing product from Life that's going to plug in and do that same job. Am I right?
Correct. Yeah, that's entirely right. Yeah.
And of course, I mean, the CAN integration or CAN communication is important in any professional level product, but I'm guessing here that at Life Racing, they're looking at CAN integration with other professional level products, maybe Bosch Motorsport ABS. They don't need to be able to talk to a Nissan R35 transmission control module or Huracan or whatever that may be. So there's a physical differentiation. I've seen products come and go over the years where essentially they started, and other than the color on the case and the brand or label, they, for all intents and purposes, the same product, sometimes at a vastly different price point. And these days with the internet, people aren't stupid. They pretty quickly pick up on that, and it's pretty hard to fool that market. So I just wanted to get that out there. Coming back to the product development, and particularly, obviously, you've got a lot of success with that Huracan R8 and then the Nissan GTR market. You kind of alluded to some of the complexities around developing a product for the R35 initially. How did you develop that skill set? Because that's, again, very different from your IT background, understanding and then decoding a CAN bus on a complex vehicle. How do you learn that?
I'm quite fortunate that I have got a lot of people around me that have good skill sets, and that's why I've kind of fell into that position now at Cyvex as more of the technical director. Is that I have the numbers of the guys that I need to speak to in order to be able to help out in those scenarios. I mean, I'm not going to be the smartest person in the room, but I'm going to have the information to be able to put the smartest people in the room to get the best from that. So I think what actually happened with the R35 is Pat Herburn, who again is one of the directors. He's one of these guys that's not really talked about. No one really knows. No one really ever knows the guys that do most of the hard work with anything, like whether it's an F1 team or kind of an ECU manufacturer. You don't know the guys that are doing the core of the development, if that makes sense. So Pat was there helping me and training me, teaching me about the CAN interfaces stuff back then. One thing I'm pretty good at is picking up stuff pretty quick. So I have quite a visual mind. I can see things quite, when I'm seeing data with CAN, I have a weird thing that I can kind of see what it is before I've even analyzed the data. So once I'd kind of got an understanding from him of how kind of the CAN system works and stuff like that, it then allowed me to build on those skill sets to do the R35 product. So pretty much all of the products that we do now, plug and play kits, obviously we do the R35 Hurricane, we've got loads of other ones with like the Toyotas and Porsches. I mean, I think we've got something like 90 plug and play kits now. Most of those I've done the development on from his training, if that makes sense. But there are cases where I don't know, I'm stuck on certain things and speak to him. So yeah, I think I've watched the video you did on the CAN stuff, and it's really good. But what makes it quite difficult when you're doing these reverse engineerings is that there's so much data. You need to be able to compute that data and isolate it. So first of all, you need to understand which identifier, which module is that coming from. So you'd basically get your car, you first of all go around and plugging everything, seeing what CAN messages drop off and understanding, okay, that message is from that system, that message from that system. Once you've isolated where those modules are coming from and the data is coming from, then you can start to analyze what is coming from those modules. So what we did with the R35 is I had to go and purchase a car because no one in their right mind is going to let me start messing around with their R35. And there were some points during that development that I was particularly nervous, I'll be honest with you. But yeah, I think once with the R35, it was a real game changer for us because we had to not only learn about the CAN system, but develop hardware for it as well. So like you said, with the Life Racing, the CAN systems are very much built around integrating with other systems like a Bosch M4 ABS system or, I don't know, Megatron or whatever they're called, their gear systems they use in the LMP cars. We needed to be able to isolate bits and bytes of a CAN structure, if that makes sense. So as you've talked about in your videos, obviously you can have a CAN which has got 8 bytes in it, and then each byte has got 8 bits of data. In certain applications, in one byte, you might have 8 functions that are there. You might have the brake switch, the AC switch, the fan, and all those things. So they didn't have the capabilities in that software to be able to do that. So we had to then provide the hardware and make the software to be able to do that, which we did as a native C code with our CAN bridge back then. We then used that to integrate between the S8 that was available at the time to the OEM car. And then basically it was like a communication bridge to be able to take the OEM data and feed it back into the ECU. And then likewise, the data that was coming from the ECU, feed it back into the car.
So you're sort of converting these messages into a format that the S8 could understand on the input side, and on the output side, converting the S8 outputs into a message that the OE controllers would understand and react to.
Exactly. And then ultimately, as time went on, it started to get quite bulky. I mean, having another module in the loom becomes bulky. And with the newer kind of cars, you have to start adding in like diodes and resistors and all these things to keep kind of an ECU that is designed to be used in pretty much any platform, which was like they say, the S8 at the time. You need to then add in features that were then designed for the R35. So one particular output might need a pull-up on it. So you then got to add a pull-up resistor on the loom. And then you've then got the CAN system. Then you've got to add a relay to the main relay control of the car. It all starts to get bulky. And that's where then the obvious evolution was the S7 ECU, which then was one we made that had basically all of the circuitry that was kind of on there to allow it to be fully flexible. That ECU that one ECU caters for pretty much all of our plugins. And it's done that via these little solder bridges that we have on electronical kind of micro switches. While they make their life easier for the end user, if they want to say use that S7 from an R35 onto say another car that needs a different type of I/O structure, the problem with them is during vibrations and in a race car situation, they fail. So these microswitches. So we basically went to we call it a solder blob, solder switch. So it allows on the board. If you ever see the inside of one of the S7s, it's got lots of these little switches to be able to integrate lots of different circuits for different particular, be it a lambda circuit for a different car. So I think we're the only ECU that's available that can support the Denso AF sensors, which are used on the Nissans and the Toyotas. So again, wanting to have everything controlled in one box was useful to basically have that evolution of the S7 Plus to be able to do it all in one box, ticks it all, if that makes sense.
Yeah, yeah, sure. That makes a lot of sense. And again, a differentiation between the two sister companies as well. Yeah, in terms of the process of reverse engineering and sort of starting from scratch with a new vehicle, and I can only assume that there's vast differences from one model to another depending on the complexity. But I mean, can you give us sort of an indication of what the time frame is from you purchasing the vehicle and sort of starting the discovery process to actually having a prototype ECU up and running, and then something that's actually ready for market? Are we talking 3 months, or are we talking a year or more?
I think it depends on the platform. Some of the cars I've reverse engined the CAN bus in a day. They're really basic. I mean, like the Subaru BRZ and stuff like that. I think it took me like a day to do that. It wasn't particularly hard. Whereas then you get like a McLaren 720 that's got 3 CAN buses on it that are all linked into the ECU. That took me like nearly a year to do. So, and the thing with those is that in some applications, you might get lucky enough to find something on the internet that describes some of the CAN information that is used by the OEM ECU. A lot of the OEM ECUs that are available on the market, there are some things that are basically describe the function of how those OEM ECUs work. You might get lucky one day and stroll across on the internet a piece of information there that allows you to get a kind of an insight, but ultimately we try to steer away from them because that's someone else's intellectual property, if that makes sense. So what we try and do is try and do everything ourselves, and it's a lot of trial and error. I mean, that's why we have the ability to update the firmwares in the field, because the thing is, we might find something that, say, particularly works on a standard normal going car, but then when someone's fitted a larger turbo or fitted something else, you stumble across problems that might not be there on the original ECU.
Yeah.
So what we strive on is being able to adapt to that situation. That's one thing I think that we do particularly well, is that when we run into these problems, we have a support structure that can fix this quite quickly for people. The ECU is able to log CAN bus from the ECU, so we can say to the customer, look, let's log in, we'll use your ECU to grab that data and then make an update, send them an update, and then like I did with the GPS with yourself, where you wanted to have an extra data on there, just send an update. Within seconds, you update it, and you can resolve those things. But coming back to the timescales, like I said, it depends on different things. These are kind of the things that I think about when I am reverse engineering a car. The first thing you've got to learn about what is going on with the engine on that particular car, whether it's got a specialist variable valve system or a lift system. It might have direct injection system. You've got to learn about where those angles are for the spill valve, for the high pressure pump. So you've got to get a DTI gauge on the engine, learn where those lobes are to be able to then tell the ECU where the spill valve has got to be working. So you're looking at datas and papers like SSPs that are provided by some of the Audi things that are available to the general public that you can pay for a subscription for, to learn about those engines, getting as much wiring information as possible for that particular car, studying that wiring coherently to kind of understand where each wire goes, what it's functionally doing. Then it's a case of scoping all of those wires with a tool like a picoscope, great tool that's like an oscilloscope that is on your computer. So you can take captures and capture that data. And then one of the hardest things, if I'm honest with you, is sourcing the connectors, sourcing those OEM connectors that are in the ECUs. A lot of the time, they're locked down to manufacturers. You go to, say, TE and say, look, I want this part number, this connector. We buy 1,000 of them? They just basically say, no, sorry, they're locked down to an OEM. You've then got to go to the OEM and get their permission to be able to use that. The OEM is going to want something in return. So be it we help them out on their rally program, for example, where we basically, like we've done with Toyota with the Yaris, we've kind of worked with them to develop that product. They now use that in their rally series. So yeah, and then ultimately once you've got the connector, you've then got to reverse engineer the CAN bus, you've got to linearize the sensors, you've got to get a base map done, which takes hours of work. So I think on the outside sometimes it looks quite easy, but there's a reason that there's not many ECU systems out there that do plug and play kits for these kind of advanced cars, because there's so many aspects of that development. So yeah, like it's coming back to Chris, it depends on the particular car that's in question.
Given what you've just said there, and I mean the 720S taking 12 months, obviously you need to factor in at the outset, and I mean going into it, you may not have known necessarily it's going to be a 12-month development task, but I'm sure you could probably sort of guess it was going to take a little bit longer than a BRZ. But you need to go into this, I'm guessing, with at least a pretty good guesstimate that there is a market for that product once it's finished, so that you're going to be able to recoup that development time. And obviously time ultimately is money. So the question here is really, so how do you highlight what's going to be that next hot platform that you think is really going to take off? And is this coming from already customer demand, or are you starting to develop these as they're sort of fresh off the showroom floor to try and stay ahead of the competitors?
I think the reason that steered us towards say for the McLaren, and it's the same for other platforms, is they use the same ECU across all of their cars. So once we knew that we had the CAN data sorted out for the 720, we knew that it was going to be similar for the 570, the 610, the Senna, the P1. They're all very similar. So while you've then done one platform, you then knew that you've got another whole heap of cars. So that's the same thing with the Hurricane, for example. The Hurricane and the 991, they share a similar CAN structure to each other. From the outset, when you look at it, they look very similar. So I can't remember which one we did first. I think we did the 991 first, and then you kind of hit a gold mine when you then connect to a car that you're thinking of doing, and you see all the CAN data is the same. It's like, oh,
job's done.
Quid's in. Yeah, job's done. Yeah. So yeah, picking and choosing which one it is, I think it comes down to, we have a lot of conversations with our dealers. We have a group of dealers that are very close to Cyvex. We have a lot of dealers. I mean, we've got like 100 on 150 or something dealers now. But there are a group of dealers that are quite close to Cyvex who have been with us from the start, who I reach out to, guys like Boyan, Ranimir, Wayne Potts, those kind of guys. Reach out to them and say, look, what have you what kind of things do you think is worth going down? And it's not just about the car that goes down. I mean, the all-wheel drive controller, which has been a huge success for us, was actually Boyan's idea. Boyan basically said to me, look, can we look at making an all-wheel drive controller for the R35? Because I'd like to be able to control it better. And I can't. I think I originally dismissed it. I was like, no, no, no. It's going to be a small market. I'm not really interested. And I think I said that about the R35 as well. I'm pretty sure I did say that. I'm sure someone will chip up at one point and say that. And it worked out to be a huge platform.
I actually remember having a discussion with a tuner in Australia, and there was a parts supplier as well, not long after that R35 got released. And it was a throwaway comment he made about he couldn't understand why there were these companies out there putting so much time and resource into developing product for such a niche platform. And that comment didn't age well. Clearly, it's become one of the most competitive platforms for drag racing, roll racing, and obviously they see a lot of track time as well.
You learn a lot as well from it. Like with the 720, there was stuff on there that you learn that will help you in the future. Ultimately, we like to kind of lead the way as I like to push my learning limits, the boundaries. I like to learn and try and do new things all the time, ultimately to try and differentiate ourselves from the rest of the market. And that's why I think we go after all those cars. The other thing that I will say is that if you notice the cars that we've kind of done, it's generally be the higher end market cars. The kind of reason for that is from my upbringing of when I started tuning cars was because when you had like a Cyvex that was being sold by Pat and Charlie to the Subaru guys, for example, they would buy this ECU that was quite expensive for the car compared to what they were used to. But then when you said to them, okay, well look guys, in order for this product to work great, you need to buy an NTK lambda sensor which wires into the ECU direct. I'd suggest you buy an oil pressure sensor, a fuel pressure sensor. If it hasn't got a knock sensor already, fit one on the engine as well. It all adds up. And then they're like, wow, I'm not spending that. I'm not paying for that. I bought this ECU. Why do I need all that? We noticed a pattern with that. Whereas with the guys that have got kind of the money to buy the R35s and stuff like that, generally when you say to them, look, in order to have the perfect scenario, you need this, this, and this, there's generally no quarrels. They would just go and buy it. When you're trying to make something that's a high-end product, that's the kind of people you want to be selling to, if that makes sense. So
yeah, that absolutely does make sense. On that note, because it sort of seems to buck that trend a little bit, you've recently released a plug and play platform for the GR Yaris, which is becoming quite a popular platform for development. But I mean, obviously, there's a significant price difference between a GR Yaris and a 720S McLaren. Why did that platform jump up as one that was worthy of your support?
I mean, the thing is that while it is a lot cheaper car than a 720, it still is fairly expensive to go out and buy for most people, kind of thing. So a lot of the guys that I know that have got a Yaris are generally already got supercars. I mean, I don't know if you've driven one, but they are heaps of fun. So the reason I got involved with it was because, again, one of our dealers suggested it. Raman from Racecar, who works very closely with Cyvex as well, he helps us out in support. He had basically suggested that I think you should look at this platform. I think it's going to be a really big thing. So we look at it, and then once we kind of get access to a car and see that the potential it's got and stuff like that, then we put all of our resources into it. It also helps when you've got a manufacturer asking you to buy hundreds of ECUs as well. That kind of helps with the development thing. But there will not be many people that make a plug and play for that car, because that car has got a security system which is ridiculously hard. I mean, this is the difficult thing for us now, is that all of the cars are becoming harder. That car has got a Seco C system on it, which basically is a secure kind of CAN system. So what it has is a CAN message that is basically, they call it a freshness frame, which it's kind of like a metronome. It basically it has like a live timestamp that's constantly going with it, and all of the other modules are looking at that timestamp, while that module is then looking at the other modules to make sure the timing of the two is in same. So if someone was to start manipulating the CAN data, it would know about it, and instantly it would shut down all the safety systems like the pre-collision, the lane assist, and stuff like that. So it becomes very difficult now to reverse engineer these cars, and you've then got FlexRay that's been thrown into the mix. You've got Ethernet that's used on it. I mean, it becomes the time frame for development now becomes longer, if that makes sense. Which is why we've started looking at smaller products like the all-wheel drive controller. We've got a load of other new products that are going to be coming out at the end of this year as well, that are a lot smaller form factor based, and the market they're aimed at, to try and allow us to kind of regain kind of development money for knowing what's coming ahead. For some of these cars, we need to be able to invest a lot of time. Like, for example, the new Supra, which has got FlexRay on it, and also the new Corvette C8. I mean, we get emails every week. When is your kit going to be ready? I mean, we've had to develop custom hardware to be able to do those. So that takes time.
For those who haven't heard of FlexRay before, could you give us the sort of 30,000 foot view of what that technology is and how it differs from CAN?
It's like another layer on CAN. Without blowing people's mind, it's generally a higher speed rate. So the arbitrary level is generally higher, and the identifiers and the bytes that are inside each identifier can be much longer. So generally on a CAN 2.0, the identifier you've got and the bytes are only 8 bytes, generally maximum per identifier. When you go to then obviously the next stage, you've got CAN FD, and then with FlexRay, each item has got its own node ID and module. So they have to basically coincide in order for the system to work. I mean, it's massively complicated, and it'd be better for Pat to fully explain it, because I'm still trying to catch up on it at the moment. If I'm completely honest, with being a technical director now, I'm kind of focusing on more of it. I know bits and bobs about it, but not enough to be able to go and reverse engineer a car on that at the moment, for sure.
That's fine. I mean, I think we just wanted to get an understanding of what it is and why it matters, which is all we need at this point. Yeah, in terms of looking at a product, a platform, I should say, like the GR Yaris, you've kind of given us some insight into some of the complexities around reverse engineering that. Is there anything that you cannot do? Technologies like the laser, LiDAR cruise control, I think it's LiDAR. Is there anything you can't communicate with and function properly?
Yeah, I mean, that system, for example, we couldn't communicate with it because it had that SecOC system on it. So we had to find ways as a plug and play to get around that. So unfortunately, with the Yaris GR plug and play kit, the lane assist and the pre-collision doesn't work. We disable that completely.
Yep.
Luckily enough, that's what every customer wants. They don't want that system on. It is quite intrusive when you drive the car. It is ridiculously, it's not great. So, and that was the reason why Toyota came to us, was because in order for them to go to Denso, for example, and say to them, look, I want to shut down these pre-collision systems to be able to use the factory ECU in these rally cars, it's huge money to do that. And then what involves then is it then starts to run into emission problems. So ultimately, OEM ECUs have got to meet an emission target now with the way the world is and stuff like that. When you start changing some of these strategies that are going to be used in a rally car, it then will no longer meet those emission strategies. So the whole ECU structure and source code of the original ECU falls to pieces. So ultimately, that's why they then come to an aftermarket manufacturer to say, can you do that? But yeah, I mean, that we just couldn't. We spent months on it trying to crack it, and the problem is, if the car then goes to the dealership, it gets an update, the key changes, or then over an air update for, say, for example, on the Corvette C8, it then changes the whole game again. So what we have to do in those scenarios is adapt, find ways to keep the OEM systems happy, but allow us to provide the tools which our dealers need in order to be able to make more torque or more power from these platforms, etc.
I'm glad you actually mentioned the C8 there. With a past guest, Hannah Westbrook, who was ex-Motec USA, kind of talked us through some of the intricacies and problems that are coming up with some of these later model cars. Like the C8 came up in that conversation as well with the over-the-air update. So, I mean, obviously that kind of direction is where we're going to see more and more manufacturers heading. What's this mean for us in the future and for the likes of you at Cyvex? Is it going to become impossible to develop aftermarket standalones for these platforms, or is it just going to become more and more difficult, or are there going to be hurdles that you're going to have to maybe eliminate the over-the-air updates or something of that nature?
I think I like to think of there's always a way to resolve a problem. I mean, but the main thing is how much time do you throw at it? And like you said earlier, knowing how much time you throw at it, 'cause time is money. If you're gonna spend like a year on something and then you only sell 1 or 2 units, it's not cost effective. You might have learned stuff in the long run of that, but that's why we haven't put the resources into looking at the C8 yet. Like we said, we get emails all the time about it, but until we've got a way to be able to do the hardware in place to be able to kind of counteract some of those problems, as well as not break the law, that's another important factor. It becomes really tricky. For example, like I mean,
Mm.
there might be a kind of a recall that Corvette release for a safety initiative. So they might have had a problem with their electric braking system or the electric steering on the car, where they found something in their source code that is on those modules that is dangerous. And they say to customers, look, you need to take your car to the dealership to have this update done. If we've then put a module in place that stops that from happening, stops the over-air updates being applied to allow our systems to keep working, that then becomes a potential legal nightmare, if that makes sense. So
Yep.
it is, it's very difficult. It's becoming harder for sure, and yeah, the way the market is changing is rapid. And that where you said about EV earlier, Cyvex EV, we haven't put too much effort into the EV stuff because the EV is evolving at such a rate that you might develop some hardware for an EV control now, but in a year's time, that hardware might be useless.
Yeah, sure.
So I don't think it's even got anywhere near its full peak at the moment. So we're kind of concentrating on what we kind of do best at the moment, and trying to make these products where people are requesting them. But at some points, unfortunately, and I hate to say it, you have to say no sometimes, and it's just not possible. We don't like to say that. We're kind of known to come and try and do any product that we can, but at some point, you
Well, I think there's also a difference between can't be done
yes,
and not economically
yeah,
viable to be done. I mean, over the whole time I've been in this industry, every sort of few years, an OE car comes out and the internet sort of says, "Oh, this will never be able to be tuned," and sure enough, 3 to 12 months later, there's options for it, and I sort of feel like there's there's so many enthusiasts who want to modify their cars. There's such a big amount of money for the industry to be made in that where there's a will, that there's usually a way. So it's just often a case of time. But yes, of course, these are becoming more complex problems to overcome.
100%.
Sorry to interrupt the podcast for a moment here, but I just wanted to take a moment to talk about a course really relevant to our chat with Ryan, that if you're enjoying this chat and you are interested in the Cyvex brand, I know is going to be super helpful. That is our practical standalone tuning course. This course teaches you how to tune any aftermarket standalone ECU using the HPA 10-step process. Now, this was developed because I know that for novice tuners just getting started out, when you're faced with a freshly installed ECU with no start file or base map, it can be pretty daunting knowing what to do first and what order to proceed in. Well, by breaking the entire process down into 10 steps, each of those individual steps is relatively quick and easy to complete, and in no time you've got to the end, you've got a completely tuned engine that's delivering great power, great torque, great drivability, and most importantly, great reliability. By following that process from start to finish, it also ensures that you're not going to overlook any critical steps that could waste time, waste money, or potentially even damage your expensive engine. Now, the course itself is generic and applicable to absolutely any brand of aftermarket standalone ECU, but once we've gone through the body of the course, we move into our library of worked examples. Now, this is an informal walkthrough of that 10-step process, and in this worked example library, we vary both the engine that we're tuning as well as the tuning platform or ECU we're using. We include a full worked example on the Cyvex brand on a Volkswagen Mark 6 Golf cup car. This is perfect for anyone who wants a more thorough understanding of the Cyvex brand, as well as how to apply the HPA 10-step process. And remember, as a podcast listener, you can use that coupon code podcast75 to get you $75 off the purchase of your very first course. And we'll put a link to this course and that coupon code in the show notes. All right, back to our interview with Ryan now. Moving on, one of the last topics I wanted to just dive into in a little bit of detail here is the actual Cyvex operating system. And what I'm talking about here, I'm not going to go into too much detail, but one element that I did want to ask about, because it sort of, I obviously couldn't ignore this when I was tuning them myself, is that you've gone with an injection time or millisecond based fuel model. Absolutely nothing wrong with that, but it sort of flies in the face of convention where we're seeing most, if not all, of the current crop of late model standalones have gone to VE-based fuel models. Now, I mean, it's essentially just two ways of getting to the same sort of result, but why have you sort of stuck to that millisecond-based fuel model?
I mean, there's so many things that tie into it, and ultimately there's many things that tie into it with our other people that use that product with LMP and World Rally Car, that means that if we were to go make a vast change like that, it would affect a lot of other kind of people that buy the product. Ultimately, what we've then done is we've added the tools in to be able to achieve getting kind of a VE-based system with the additional maps being applied on top. So with the relative fuel pressure trims, the lambda target adders and stuff like that, as CM maps being applied on top of that. At the end of the day, what you're driving the injector is going to be the same, be it if it's via VE system or a fuel millisecond system with the appropriate maps on top of that with a compensation. At some point, I do want to look at changing it over to a VE system. The reason for that is it links in better with all the torque stuff that we're doing at the moment. So there's about to be a rather large firmware update that's coming for all of our ECUs that is going to be all like torque based with mass airflow. Having a VE based system then becomes a lot easier to link in those strategies. But with DI, in some ways, the fuel millisecond system actually is easier to actually get better control. With DI, you're limited on how long you can physically inject into the engine in a particular angle of a window. And being a time-based system, that becomes a far easier way of being able to do that. We found,
I'd agree.
So that's why, from that, the way that the market's changing, I haven't actually run into a need at the moment on any of the calibrations or base calibrations that I've done to actually feel that I've needed to change it to a VE system at this present time.
Sure.
I mean, the guys that write the source code, they basically joke about the VE system and basically saying it's how many bananas do you want to fill the engine with, kind of thing. It's at the end of the day, you still get to the same thing. But yes, look, ultimately, as I've said, for the ethos of Cyvex, we like to constantly improve. It is something that we're going to do. Do I feel the need for it right this second? No, I haven't run into that problem as yet. I mean, the comp map system on the Cyvex, I don't know, I'm sure you've used it, where you can basically create your own maps now. It's so powerful that you can basically, some of our calibrators have made their own VE system themselves anyway, and we can do that with the base maps to be able to set that up if needs be. You can basically just zero out the whole fuel table and then make all the additional fuel tables you want in CM maps that apply on layers. So you can make one comp map, and then you have another one that layers on top of that one. Another one. You can basically make your own strategies. It's super powerful, and it's a really useful tool for that. But yeah, like I said, it will come at some point. But at this given time, it's not on the price list. The torque control is, we've got torque control already that's on the system, but better ways to be able to do that from a mass airflow basis of throttle mass is the changes that we've got coming in the next couple of weeks.
I think it's probably also become, or as I've seen it, maybe almost VE became a bit of a marketing tool that some of the manufacturers were using. And I mean, how many bananas do you want to put into the engine? Essentially, it's just two different ways of getting the same result. I grew up learning to tune on injection time-based ECUs. It's a bit of a learning curve jumping to VE. I'm familiar and happy with either of them. Probably one of the areas I see maybe a potential distinct advantage with VE based is on flex fuel, because essentially, for all intents and purposes, the actual VE of the engine is not changing as we move from pump fuel to ethanol. Yes, there's a potential for a small amount of in-cylinder cooling, so it's not a blanket statement, but for all intents and purposes, we're there or thereabouts. Whereas obviously with injection time, you're physically going to need to add somewhere in the 35 to 40% more fuel injection time or fuel mass when you move from pump gas to E85. So I sort of see some potential there, but I mean, again, doesn't mean to say that it can't be done.
One thing I would just say, sorry about the VE, is that it does make life easier for people that are just getting the product. If they can just go in and just change their injector size and that's all they need to do, the product becomes easier. One thing that we strive at Cyvex is to make our base maps as good as they possibly can be. I think when you use the TFSI product, you just got that product in, you plug it in, and it just starts up, and it's pretty close. I mean, our Yaris base maps and our Hurricane base maps, I'm pretty confident in saying that you can basically put those in a car, even with a turbo. You provide a base map for it, and they will be like 90% done, if that makes sense. And if
Certainly.
you make the job easier for the dealer and the calibrator, they're going to want to use it again. So that's where some of the benefits with the VE will be better, is that it makes it easier for calibrators that aren't, say, at a higher level. They can get to where they need to be quicker, if that makes sense. But you're entirely exactly right about the flex fuel, and there are other obviously things as well. So when it comes to DI,
Yeah, the fuel injector swap, as you mentioned as well, probably overlooked that. But I mean, yeah, for all intents and purposes, the theory being if your VE table is calibrated properly on one set of injectors, assuming that they're characterized properly and the data's in there, swap to a larger set of injectors, put the new data in, and it should basically run at the correct lambda. I mean, that's always the theory. I haven't always found it to work perfectly, but I mean, certainly you should be within a few percent. And again, as you say, making the tuner's job easy. Now, I've said lastly already, but honestly this time, last question here on the product before we get into wrapping this thing up. Along the same lines of the millisecond-based fuel model, when you jump into the Cyvex software for the first time, and this isn't knocking the software, but I would have to say it is very different to anything that I had used before. And initially, and again, not to offend you here, initially I felt it was a little bit clunky. And I had the benefit of going through some in-person training with you, or team viewer training with you, before I jumped into this, and we added a worked example on the Cyvex platform. Once I got familiar with it, it all kind of just fell into place and made sense. But I know a lot of people using it for the first time will probably go through that same learning curve that I went through. So can you tell us why that Cyvex user interface is designed in the way it is?
Well, I think first of all, we did it to scare people. So, like you said, where you didn't have the password in there, if someone then opens up the ECU and looks at it, oh God, I'm not going to touch that. So, yeah, that was the one of the first reasons. You get rid of all of the novice kind of tuners from using it, in a way. But that isn't a good thing. And obviously, when you're trying to sell products, obviously you want to make it. You've got to. Originally, when the user interface was set up, it was designed around a race environment, if that makes sense. So what I mean by that is that everything in the software has got a keyboard shortcut. Every function. You don't need to press, say, Alt and then P to get your, I don't know, one table up, for example. There's just one letter that basically differentiates each of those functions. It's been designed really well, and I think in terms of the hotkey structure, so that basically you can operate it with one hand. So if you're in a moving vehicle or on a dyno or even at a racetrack, you're limited with space. You need to just get in there quickly, pull the log, grab the data, or make a quick change. You can do it with one hand and just reach in and get it in that. The other thing is that when you've got a user interface that is all touchpad based, which a lot of other ECUs are, with a cursor, they're no good in direct sunlight. You can't see the mouse cursor in direct sunlight. So you're sitting there. If you're outside, calibrate. If you're on the dyno, it's great. You can sit there. You're happy as Larry in a nice warm. You got the AC on. As soon as you get outside and you've got direct sunlight, if you haven't got a screen that's got a high nits in brightness, you then suddenly can't see the cursor. So you're then squinting. You then can make mistakes. Having the color scheme that we did was done for that scenario, for the sunlight. not having to use a touchpad. You never have to use the mouse to navigate the whole thing. So it makes it super quick. If you see some of our top dealers using the software, they are flying around it. There's no way that someone could get anywhere near as close with a touchpad-based system. And the other thing is that where it doesn't use much resources. So, for example, my ThinkPad will go like 12 hours calibrating on SCAL because it's not graphically. It
Intensive.
doesn't use loads of it doesn't use loads of graphical intensive power and stuff like that. It's just designed to do a job, and it kind of merged over from the Despro Pectel days. I mean, Mark Colby that designed the system completely out. He wrote all the software for the Pectel system, and if you look at Despro, which is a Pectel, you'll see the similarities with our software. So yeah, I think personally, when I look at using other systems now, I find it really a pain when I'm having to constantly like use the mouse cursor to get to different tabs and different windows. But it's just each their own. Like I said, when you first look at it, I think yes, it can look a bit daunting and, like you said, maybe a bit clunky. But like you said, once you start using it, it just flows. Everything is where it needs to be. And I think that I've read comments on the internet where like some calibrators have looked at it and only kind of looked at like you don't read a book by its cover, kind of thing like that. You see the first sight of it and go, oh my god, that is horrendous, that's terrible. But they've never used it, so you can't comment on it until you've actually used it. And then once you do use it, I think a lot of our calibrators do calibrate many types of ECUs, and the feedback that we get is that we wouldn't want to. We try and use your stuff as much as we can because it just works for what we need.
I mean, I think a lot of the aftermarket ECU brands, I mean, I'm only guessing here from what I see personally, they put quite a lot of effort and resource into developing a user interface that looks pretty, and you know that's nice, but pretty doesn't make the car drive any better. And what I see from Cyvex is the development has solely been around making it work and work efficiently. And what I would say is, I mean, like any system, that there's a learning curve associated with it. But you're absolutely right. Once you're familiar with those hotkeys, and I mean, there's a lot of them, but there's only also a handful that you're going to be using consistently. It does become very quick and easy to navigate, and I found that it was not too long before I was really familiar with it. The other thing you mentioned as well, using a trackpad or a mouse. I mean, when you're bouncing around in a car, even on the dyno, often the car's moving or vibrating, and that can make it quite difficult to be precise when you're trying to find a particular menu. So not needing to do that, definitely a huge upside. All right, Ryan, we'll move on to our wrap up, and we end all of our podcasts with the same three questions we ask all of our guests. And the first of those questions is, what's next and in the future for you and Cyvex?
Me personally, is kind of just keep doing what we're doing. I don't envisage being in this industry forever. So at some point, I will probably look at getting away from it. There's only so much kind of fumes and car fumes and loud noises, and these cars are getting so fast now that I even get nervous going in some of these cars. They're just ridiculous. I mean, I went in a 3,000 horsepower, no, it was 2,500 horsepower R8 the other day, and it was just like one small mistake, and yeah, it's game over. So I have two children now. I think that I'm just going to stick to more behind the desk as much now, developing products and just keeping making things that dealers want. I think that's the main thing, is listening to what your customers want and developing those. But for me personally, I don't know. Maybe when the big 40 hits, maybe I'll have a change of a slight change of career in 4 years' time. But for the moment, it's just keep doing what you're doing.
Sure. A couple of things I'll point out on that, and because my career has had some similarities to yours, particularly around the tuning, maybe not the ECU development, but I mean, you mentioned the fumes, and I've spent my share of time of calibrating engines on methanol and all sorts of nasty C16 VP import, Q16, all sorts of nasty fuels that probably have a bunch of chemicals in there that shouldn't be inside of your lungs.
Yes.
So, you know, I think you can't put too big an emphasis on your health
Yeah.
and your safety. And I wish I could have gone back maybe and now invested a little bit more in my health back then. Can't take that back, of course. So probably taking a few of the years off the end of my life. Hopefully those will be the shitty years that no one wants anyway. That's just an element that we do need to understand. There's a risk associated with it, and as you mentioned, these cars get fast. I never really liked going for a test drive with customers. That sort of always made me a little bit nervous. I don't think I've ever seen anyone crash their office desk at 140 mile an hour, so you're probably safer there. Next question for you, Ryan. Is there any advice you could give to our listeners or even to a younger version of yourself to maybe help fast track your career progress and maybe avoid any pitfalls you've come across, get you where you are quicker?
I think one of the things you just said hit the nail on the head. Obviously, safety kind of thing. One of the things that I wish I'd done probably from the start when I was working on dynos is have a better extraction system. Not only does it allow you to get more accurate data, especially when you've got higher powered cars. The more the higher power, the more exhaust energy is coming out, the more fumes you've got. So having an extraction system with your setup that is good and can get all of those gases out is vital. Many times I've tuned a car on a dyno and then gone on the road and it's like, what? Why is this air fuel ratio changed? And it's because before it was just sucking in so much NOx and carbon monoxide from the engine. But yeah, I think that is one of the main things that if I was a younger version of myself, I'd probably say that I'd wish I had kind of invested more and been more careful in those kind of things. I suffer now. I get like kind of patches of eczema from like where I think it's got to be the chemicals in these fuels and stuff. I don't know if you suffer with any oddities like that yet, but I think as a younger self, just wearing a mask, kind of investing in the safety stuff, and then just having a decent exhaust system. Everything else so far has been pretty good. There's nothing else that I can think of off the cuff that I would say apart from just reading as much as you can, investing in the right tools for the job, and getting yourself around the right group of people, if that makes sense. What I mean by that is that you've always got to accept that you're never going to know everything, and there is always stuff that you can learn. You might think that you know everything, but you don't. There was parts of my years of my life where I thought I knew everything, and I clearly didn't. So one thing I would say to people is kind of always go into a room with an open mind that you are going to learn something. Every day is a school day.
Yeah.
So I think that's why HP Academy's done so well.
That's a really good point. I mean, the old sort of saying that you don't know what you don't know, and it is 100% true. There's the Dunning-Kruger effect as well. People who haven't heard of that can go and Google it, but essentially is that sort of path of going from zero knowledge to learning a little bit and all of a sudden thinking you're an expert. And I think what doubles down on this is that there is a level of arrogance, let's be honest, in the tuning industry. And I think most good tuners probably need to have a certain amount of arrogance. You need to know that you know what you're doing and be competent. But there's also a point where that goes too far, where you think you know everything and don't need to listen to others. Be humble and always understand that no matter how much you think you know, there is always more to learn. And in all honesty, that is why I still, 20 plus years on, really enjoy my time in this industry, because I am always learning new things. Technology is always evolving, so it's never stagnant. There's always more to learn. Just one more sort of anecdote on the extraction system, and this will stay with me to the day I die, and maybe it might cause that, I don't know. I spent some time tuning some rotary drag cars which ran on methanol fuel, and the rotaries, of course, have the exhaust come straight out the side of the front guard or wing, as you call it in the UK. So it's not really ideally set up for any dyno cell, and there's no real way of sort of routing that to the rear of the vehicle, which is where our extraction system was. So I remembered what I'd have to do, because I had no air supply that I could physically breathe. Even though there was a lot of air moving through the dyno cell, we'd sort of get in the car, start it, warm it up for 30 seconds or so, and then do a dyno pull. And I'd basically, towards the end of that dyno pull, be holding my breath. I'd let the engine come back to idle, let it idle for the bare minimum time I felt I could before I could shut it down and not risk damaging the turbo, and then literally run out of the dyno cell with tears coming out of my eyes. And when you look back at that, you're like, yeah, no, that's pretty stupid. What were you thinking? But, you know,
How
at the
much,
heat
how
of
much
the
did you get
moment,
paid for that?
not enough. Actually, I think I was doing that job for free for a mate of mine. So, you know, what price do you put on your health? But anyway, I don't want to sort of continue beating that one, but
It's important.
just important to mention. Right, last question for today, Ryan. If people want to follow you, find out what you're up to, see the Cyvex brand and products, where can they go and do that?
So we've got a Cyvex Facebook account and Instagram account. That's the best place to follow. I have got my own personal one. It's a mixture of house building stuff at the moment, as well as I don't really put much car stuff on there at the moment. I've kind of just been building a house in between work and the weekends, much to my wife's hate. So yeah, but the best ones are just the mainstream Cyvex, limited on Instagram and Cyvex on Facebook for sure.
We'll chuck a couple of links in the show notes to those accounts so people can find them nice and easily. Look, been great chatting, Ryan. Great to get some insight into your background as well as the Cyvex brand. And we really appreciate your time. Thanks for coming on.
Cheers.
If you enjoyed this episode of Tuned In with Ryan from Cyvex, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Jesse99875 from the United States, who has said, a hidden gem for enthusiasts. I stumbled onto this podcast via YouTube, and I can't believe the amount of knowledge being given. It's criminal that this podcast doesn't have more traction. Well, thanks for the kind words there, Jesse. Great that you're enjoying the podcast. And if you reach out with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.